Now we want to graph f of x equals the absolute value of x minus 3. Now I've made an extensive table here, not because we need an extensive table to graph this. We can graph this function very easily by graphing the absolute value of x. And the absolute value of x is equal to x in the first quadrant, so the absolute value of x has this graph where the y equals the x. Okay, so you have 1, 1, 2, 2, and so forth. But all you need to know is you have the origin, and let's say 4, 4, and you draw a line through those 2 points, and you've got the graph of y equals absolute value of x for the first quadrant. Then y equals absolute value of x is symmetric with respect to the y-axis. Why? But you can work it out and you can test it, but it just comes down to the absolute value of negative x equals the absolute value of x. So that we reflect the first quadrant graph through the y-axis and we get the second quadrant graph. So here's our graph of y equals absolute value of x. Now, when we subtract 3 from x, x is going to have to be 3 units bigger to give us the same y value that we get on this graph. And that shifts the graph 3 units to the right. Now the reason I made this table is to illustrate that shifting in a little different way. So here's our table. We have our x values from -2 to 5. I just chose those values because those are the values I chose. Okay. And absolute value of x, well, we see what those values are. Absolute value -2, -1 is 2 and 1, and then all the rest of the x values are non-negative, so the absolute value is just equal to the value of x. Now, if we do absolute value of x minus 3, well, when x is -2, x minus 3 is -5, and the absolute value of that is 5. When x is -1, we get -1 minus 3, which is -4, and the absolute value of that is 4. And so on. We can do that all the way down here. Finally, when we get to x equals 3, we get 3 minus 3, which is 0, which is the place we're going to see the 0 of our absolute value of x minus 3 function. And then we're going to get value 1 and value 2 and so forth. Now, the thing we want to notice is that these x values, 2, 1, 0, 1, 2, repeat over here. 2, 1, 0, 1, 2. And then from the obvious progression of these numbers, we know that this is going to continue 3, 4, 5, and so forth. And if we're at 5 here, then we had 1, 2, 3, 4, 5 going this way. If x was -3, we would get 6, 7, 8. So we get just continuing counting numbers in this direction as well. Now the values then 2 through 0 through 2 repeat down here 3 lines later. Okay? X is 2. Absolute value of x is 2 when x is -2. Absolute value of x minus 3 is 2 when x equals 1. Okay? And then at -1, absolute value of x is 1. We have to go 1, 2, 3 units to find absolute value of x minus 3 equal to 1. So again, we see that the graph is going to shift 3 units to the right because the numbers are going to be 3 units further along in comparison with the x values. In particular, say, we have the point 0, 0 on the absolute value of x graph. We have the point 3, 0 on the absolute value of x minus 3 graph. So the absolute value of x minus 3 graph shifts the absolute value of x graph 3 units to the right. In general, if we replace the value of x in if we replace x in one function, like absolute value of x, by x minus 3, that's going to shift the graph 3 units to the right, and that holds for any function, not just the absolute value function. And of course, if we replaced x by x minus 10, we would shift the graph 10 units to the right. If we replaced by x plus 10, that would shift us 10 units to the left. So there's a rule involved with replacing x by x plus or minus some number.